People still think that JAX equals TPU only. Let's break that myth fast. Here's an NVIDIA GPU and here is JAX, and yeah, JAX devices GPU detected. So if JAX runs on GPU, then XLA compiled training runs on GPUs as well. Which means we can fine-tune Llama 3.18 billion on NVIDIA hardware using JAX. I built two real demos that do exactly that on NVIDIA GPUs. I'm using MaxText for full supervised fine-tuning and Tunix for LoRa and QLoRA. So pass 1, MaxText full SFT, the big rig mode. Full fine-tuning trains everything, so the demo targets multi-GPU systems like 8 GPUs with 80 GB plus each. Single machine, JAX finds your GPU automatically. Multiple machines, set the coordinate address and initialize distributed. You then authenticate to Hugging Face, grab the gated checkpoint, and convert it into MaxText format. And here is a pro tip. Do the conversion with JAX platforms equals CPU to save GPU memory. Then launch the training from an SFT YAML config. The notebook runs a quick 100-step demo on UltraChat with 1024 tokens and bfloat 16, and you can watch loss in TensorBoard. Pass 2. Tunix PEFT, the lightweight mode. QLoRA can fit on a single GPU with 16 GB plus VRAM, while LoRa is happier at 24 GB plus. Devices like DJI Spark are perfect for this scenario. Tunix builds a mesh that adapts to your GPU count and then auto-model from pre-trained, downloads, converts to JAX, and shares correctly across that mesh. And here's the magic. You keep base weights frozen and inject adapters into attention NMLP layers. QLoRA uses NF4 4-bit tile size 32. It trains on a small UltraChat subset, evaluates every 25 steps, and after the first JIT compile, it flies. So choose QLoRA or LoRa for fast iteration and lower VRAM. It's best for style or format shifts and lightweight domain adaptation. Choose full SFT when you need deeper across-the-board behavior changes and can afford the compute plus evaluation overhead. That's JAX on NVIDIA GPUs, from GPU detected to fine-tuning Llama 3.1 in 2 ways. Try it yourself and let us know what you'll be using the fine-tune model for.